that called Scrabble? All right. This quiz that you just got back and took last Tuesday is going to be part 3 of your Test 3 review packet. Test 3 is this Friday. Wow. Remember? This Friday is our first test of the quarter. That test will become 65% of your overall grade. Traditionally, 60, 65. Close enough. Traditionally, people do better on the second test than the first test, and I think motivation is the reason. I think, as the quarter comes to an end, it's like, oh, crap, I better pick it up. So let's try not to do that. Let's start the quarter strong. And then, put yourself in a position your grade can go nowhere but down. Not nowhere but up. All right. Let's look at number 1. Number 1 was a bit of a toughie. Cosine theta over 1 plus sine theta equals 1 minus sine theta over cosine theta. It's really easy if you're allowed to just cross-multiply this equation, right? Cosine squared equals 1 minus sine squared. Duh. But not allowed to do that. There's so many different ways you could do this. We could take the left side, multiply both top and bottom by cosine. That would work. Or you could take both the left side and multiply by 1 minus sine, top and bottom. That would work. You could take the right side, multiply top and bottom by 1 plus sine. That would work. Or you could take the right side, multiply top and bottom by cosine. That would work. Lots of different approaches you could take here, all leading to a completely valid proof. And really the work is equal no matter which of those methods you choose. I have a feeling the most common approach is probably multiplying top and bottom by cosine. No? Yes?
1 minus sine.
All right, 1 minus sine. So we'll multiply top and bottom by 1 minus sine. If you multiply by just sine, that won't work. Okay, so for the top, we end up with cosine theta times 1 minus sine theta. And the bottom becomes 1 minus sine squared theta. Okay. Quit winking at me. All right. Next, 1 minus sine squared, according to the Pythagorean theorem, Pythagorean identity is cosine squared. Of which you big guy.
If I don't catch it.
This cosine cancels with one of the cosines in the denominator. And that's it. So multiplying top and bottom of the left equation, on the left side by 1 minus sine. Pythagorean identity, cosine cancel, good to go.
Wait, wasn't the 1 minus sine the parentheses?
No. It's 1 minus sine squared becomes cosine squared. 1 minus sine is just 1 minus sine.
So then how do you cancel it? Oh, because it became 1.
Okay, let's look at number 2. We have sine theta over cosine theta plus cosine theta over sine theta So then, if we get a common denominator, so multiply top and bottom of this left fraction by sine, multiply top and bottom of this right fraction by cosine, then we will end up with
a common denominator of sine cosine, and the top is going to be sine squared plus cosine squared. So I kind of did two steps in one there. I not only got the common denominator, but I went ahead and combined them as a single fraction as well. What is sine squared plus cosine squared? So we have 1 over sine theta cosine theta. Well, does everybody agree that 1 over sine cosine is the same thing as 1 over cosine times 1 over sine? And so therefore, on the left side we have secant, cosecant, and that's the end of our proof.
Okay? So that one was pretty simple. A lot of people did pretty well with that. Just get a common denominator, add them together, Pythagorean identity is 1, you're good to go. Number 3, we have sine of negative theta. First thing I'm going to do is my odd function identity that lets me rewrite that as negative sine theta. I'm also going to rewrite cotangent as cosine over sine. Here the signs cancel, and so we end up with, just negative cosine. Some people made that way harder than it needed to be, right? There's a handful of people that I'm seeing some things like multiplying top of this fraction by something and then the other fraction by something else, like not really understanding the whole idea of not changing the problem, right? I saw some people like, I'm going to multiply by the opposite reciprocal. If you multiply something by its opposite reciprocal, you're changing its value, okay? You're changing the problem. You got to make sure from one step to the next, you're not altering anything. So like multiplying top and bottom of a fraction by something. Okay? Canceling when you have something in numerator and something equal in the denominator, things like that. Number 4, secant minus tangent sine. So that is 1 over cosine minus sine over cosine times another sine, so I'm going to call that sine squared. Those fractions already have a common denominator, so that becomes 1 minus sine squared over the common denominator cosine. 1 minus sine squared is cosine squared. A cosine in the numerator cancels with the cosine in the denominator, and we have cosine equals cosine. Okay, any questions over the proof? Okay, how about the graphs? So the first one is just the parent function sine x. So you're going to label this pi halves, pi, 3 pi halves, 2 pi. Maybe 1. Every problem is 4 points. 4 times 7, 28-point quiz. So we've got nice, happy parent function for sine. I think combined of all of my students, I took 1 point off for this whole problem. Okay. Pretty good? Good. Next. Negative 2 cosine x minus pi fourths plus 1. The trick here is the fact that the period of this function is 2 pi, so we would love to label the x-axis by pi halves, but we're going to have to shift it to the right pi fourths, and that doesn't really line up really well. So I would love to just label by pi halves, but because that shift to the right pi fourths, I'm probably going to choose to label by pi fourths. So we got pi fourths, there's our pi halves,
3 pi fourths, pi, and so on and so on. So I think this is going to be 2 pi right here. Negative pi halves. Yeah. I graded it, no matter how it was labeled, I graded it accordingly, and that was good. Some people had like varying, like they'd label this as like 1 and then label this 2, and this would be 0. I was like, what? So, don't do that. Okay. And then how can we label this? We call this 1, 2, 3. Okay, does that look good? So how does this work? We've got the point 0, 1. It's going to come down here to 0, negative 2. It's got to shift to the right pi fourths, and then shift up 1. So you should have a point at pi fourths, comma, negative 1. The next point on the parent function is pi halves 0. Stretch reflected doesn't go anywhere. Shift to the right, pi fourths, up 1. So you should have a point at 3 pi fourths, comma 1. The parent function has a point at pi negative 1. That's going to reflect and stretch up to pi 2. Shift to the right, pi fourths, up 1. So you should have a point there. And then once you do that, you should notice the pattern. So you should have a nice, happy cosine. Well, something like that. Okay? These are surprisingly easy to grade. I enjoy grading this quiz, actually. Basically, just as long as you have the right period, you had the right amplitude, and then had it going. If your graph had the right period and the right amplitude, I just looked for one point that was correct, right? If that was the case, you're good to go. So basically, I've taken 1 point off for a wrong period, wrong amplitude, and wrong point it was going through. So it wasn't very often I took 4 points off unless you just left it blank. So it was almost like 1 point was a gimme. And then finally, 3 sine 2x plus pi. Now for this graph, the period is pi. So I would love to label the x-axis by pi fourths. But, now let me rewrite this in factored form. That's 3 sine 2x plus pi halves. Can I shift to the left pi halves if I'm labeling by pi fourths? Yes, that is great. So we're going to label by pi fourths. And then maybe go by 1, 2, 3. Some reason mine's cut off, so I'm going to say 1, 2, 3. Like that. Sound good? Okay. Parent function signs at 0, 0. Vertically stretch, horizontally squash. Shift to the right, pi halves. So we should have a point right there at pi halves 0. What's that? I don't. Okay. Then, just because I wrote for it doesn't mean I'm going to be graphing there. Alright. So, the next point on your parent function is pi halves 1. We need to vertically stretch that by 3, horizontally squash that by 2, and then shift to the left pi halves. So we're going to be right here. Okay. We're shifting to left pi halves. Technically, the origin goes to here. There we go. Next, sine has a point at pi 0, or vertically stretched by 3, that doesn't move it. Horizontally squashed by 2, and then shift to the left pi halves. That is where we get the origin point. Your parent function usually has a point right here. We vertically stretch that by 3, horizontally squashed by 2. Where does that go? and then shift to the left by halves, and by then you should notice the pattern. And that's it. Any questions over the graphs?